What's going on, everybody? Zane here, back with another video. For this one, we're going to go over question number 981, which is the time-based key value store. So here, essentially, we're being asked to implement a time map. A time map is essentially just a regular hash map, except the value portion is not just one parameter. In this case, we've got two parameters that'll be stored as our value. And in this case, it would be the string value and the int timestamp. So if we were doing a regular hash map, this would be a little bit easier, but we're doing it as a time-based. So that's where the timestamp comes in. So our task is to initialize this data structure, create the void set function, and then create the string returning the get function. So first thing what we want to do is we need to establish what data types we're going to use. So since we're dealing with a key value store, that to me tells me is immediately going to be a hash map. So let's first create a map of type. And now for our first value, for our key, the key is always going to be a string. And there's only one key, of course. So in this case, our first parameter is going to be string. Now for the second parameter, that's where it gets a little funky, because not only is it a value, but we're also storing it as a timestamp. So when we're encountering an issue like this, what we could do is we can create our own data type that would essentially be a list that'll store some data. So instead of saying a list of a string and a timestamp, or whatever the case is, what we could do is we'll just say a list of data. And you know what? Just for simplicity's sake, let's just keep it as data. Yeah. I'll close this out. We'll call this map. And we're being instructed to initialize our data structure inside of the time map. So instead of initializing it here, we could just put it here. We'll say map equals new hash map. So our map is done here. Now let's create our data class. So what we're doing here is creating our own data type. So inside of our time map class, this entire class here, we'll create a new class. We'll call it data. In here, what is our data? So our data is going to be part of our list of data, and our list of data is comprised of a string value and an int timestamp. So we'll just create those two. So we'll say string value and int timestamp. Now we just need to initialize the actual constructor. So we'll say public data. And inside of our signature, we just need to add the same thing. So string value and int timestamp. This is basic Java here, so it might be different for the language you choose, but here we instantiate the constructor, and now we'll just say this dot value equals value, and then this dot timestamp equals timestamp. So now we've created our data class, and we created the constructor, which essentially creates or gives the infrastructure for what a data type is. So now that we have that, we can use our list of type data. Now let's go to our set function. Our set function is just going to put a value or set a value inside of our map. So since we've already created a map, what we could do now is we could check to see, is the key that we're given inside of this function, does it exist in the map or not? So we could use the if map.contains_key function to see if this value of the key exists. And since we want to check to see if it doesn't exist, we'll add our not here. So if the map does not contain the key, then what we could do is we'll just put the value of a key. So when we're putting something into a map, we'll typically put a key and a value. So in this case, we have our key, that's the basic map function or functionality. And then our value is going to be a list of data. So instead of putting a list of data, we could just put a new array list. That'll essentially be a fresh list, since we don't technically have data for it yet. Now, otherwise, if we come out of here and we say, okay, the map does contain the key, Well, since this is a void function and we're setting, what we'll want to do is we'll first get the value of the key, and then we'll add that to our map. So what we need to do now is we've got the key, and now we just need to add the value of our actual key value part. So we need to add the value of our value. So we have a key value store. We've got the key now, and let's just add the value. And the value here is going to be a list of type data. So all we need to do is, since we've already given data our constructor, what we could just say is we'll add a new data, and in here we'll pass in the value and the timestamp, just like we've typically put in a value of a map. So now that we've set our value, what we could do is go down to our get function. We kind of want to use the same logic here, where we're going to say if the map does not contain the key of the key, well, if that's the case, then we can't actually return a string. There's nothing to actually return. So we could just return an empty string. Now, let's just assume our map is not empty. And now we need to get some value. Well, the value here is going to be based off of our timestamp. So here, our get function is going to return a value such that set was called previously, which is already completed, and the timestamp previous is less than or equal to the timestamp given. So we need to first figure out what is the timestamp that is currently in our selection, not just what we're given here. So what we could first do is we can instantiate some list of type data. And this is just going to be the value that we're currently at. So list of type data is going to equal map.get the value of the key. So the reason we're doing this is because we want the list of type data. And the list of type data can be obtained by getting the value of the key, because the key is here for our map, and then our value is technically these two things, which is the list of type data, which is why we're obtaining it here. Now, once we've got our data, I'm going to call this data. So list of type data equals map.getKey. Now that we've got our data, we need to now first find what is the closest value that will allow us to return some string that is either less than or equal to our timestamp. So we can create some helper function, which will be our binary search function. And what we'll do is we'll return binary search, and we're going to create this function here. So just bear in mind. So we'll return a binary search using our data, or our list of data, which is going to be data. And we're going to pass in a timestamp, because those are the two things we're concerned with. We need to use our timestamp to compare the two timestamps here to see what is the correct value. And of course, we're going to have a list of type data that we're going to use to actually do the search. So this is what this function will return. So now we need to create our binary search function. So we'll just say, I think best practice here would be private. This is going to return a string because this one returns a string, and we need to return whatever the binary search call returns. So private string, we'll call it binary search, is going to take in a list of type data. Let's call it data, and an int timestamp. Now, for binary search, we're typically going to use a while loop with left and right pointers. So our left side is just going to be the far left, which is 0. And our right side is just going to be the size of the entire data structure, -1. Just like we have it similarly for arrays, where we'll do arrays, we'll set I to be 0, and then j to be maybe the array's length -1. It's the same concept here. Now we could say while left is less than right. Now we're going to need a middle, because the whole purpose of a binary search is we're taking advantage of a what's the right word here, of a property of a specific data type, such as this one, which is sorted, which we're being told, I think it's down here, all are strictly increasing. So it's sorted. So what we could do is we'll set our left and right pointers, and we'll start off at the middle somewhere, and the middle will be left plus right plus 1 divided by 2. Typically, we would just do left plus right divided by 2, but in this case, we're accounting for a 0th index, so we need to add 1. Otherwise, it's going to exceed your time limit. Technically, you could actually take this out and then run your code, and you'll be like, okay, the time limit is exceeded, and perhaps you might even get an error, and then you'll kind of be able to tell, okay, maybe you need to add another 1 here, just to make sure that it doesn't get stuck. Now, we've got our mid value, and we got our left and right. Now, depending on what the mid value is going to be, we're going to update our left and right. So, for example, if the value was maybe larger, we'll decrease from the right. If the value was smaller, we'll increase from the left. And let me show you what I mean by that. So now we've got our mid, and now let's see what the value at mid is. So if we get the timestamp at mid. So if we do data.get the value at mid and get its timestamp. So now we got the timestamp at this data value's mid. And if that is less than or equal to the timestamp that we were given, then that means that our left side will now become mid. And the reason for that is because it is less than or equal to the timestamp we were given. So the left can now be pushed up to mid because we now don't care about the values on the left side. Those are not necessarily going to be the strings that we need. Now, on the opposite side, if it's not the case, we'll just say that right is going to equal mid. And to ensure we don't ever overlap on our values, we need to subtract 1. Now that we've got our binary search technically completed here, now we'll go down, and what we could do is we'll extract our data, and we'll say that the data closest value is going to equal data.get, and we'll get the left side. Now, when it comes to binary search, we're always looking on the left side or right side, depending on what the question is asking. So on the left side, since we're being told that these timestamps are strictly increasing, we'll know that a smaller timestamp is on the left side and a larger timestamp is on the right side. So our closest value will obviously be on the left side because we want it to be the most optimized value. So yes, it might be less than, and yes, it could be equals to, but we would prefer the lower value or the closest value to our target, which is our timestamp. So now we've got our value for the closest, and now we need to return a string for this entire function. So what we'll do is we'll return some value, and we'll compare the closest value, and we'll say closest value dot timestamp. Is it greater than the timestamp we were given? If so, we return a blank value because we are not able to go past the timestamp. It must be less than or equal to the timestamp we're given. So if it's greater, then we just return a blank value. Otherwise, that means it's in bounds. So we'll just take whatever the closest value is and return its value. And that should be it. So let's run this, see if there's any issues. Looks good to me. Let's submit this. I did have to try a whole bunch of times here, but was finally able to get this. Binary search is a very powerful tool. So let's recap real quick. I'm going to minimize this, and I think this is very important to be recapping because a lot of people just kind of solve it, then disappear. So we first established our data types. That was my process. I'm like, okay, I see a key value store. That means that we must be using a map. Now for the map, what are we going to use? Well, the key is a string, so we can just say string up here. But then we've got a time-based key value store. So we're going to have a value that'll have multiple values. So we'll just say it's a list of some data type. And that's why we said list of type data. Then down here, we just created our data class and then created the constructor for it, which just comprises of value and timestamp. Next, for our set function, right before that, we just initialize our map into our time map. You could technically actually take this out. Like we don't even need this. And we can just leave it there and leave that blank. And we can submit this and that should work still. Yeah. Strangely enough, I'm not actually too sure why, but we're being told specifically initialize your data structure here. So that's what we're going to do. I think that's very important to be reading what they're asking. But anyway, next would be the set function. It is a void, so we're not returning anything. We check to see first, does the map have the value of our key? No? Okay, then put it by putting the key, which we're given, and then a new array list. Next, what we could do is, otherwise, we need to actually do the set of our map. So we'll get the value of our key, and then we'll add the value. And that value is just going to be the data type. So we'll just say it's a new data of value and timestamp, which is why this constructor comes in. Next, we get our get function. Our get function is going to first check again, does the map contain the key? If it does not, okay, well, we just return an empty string because the map doesn't have anything for that key. Next, we'll create a list of type data, and we just get the value of the key. And the value of the key of the map is going to be, at this key, a list of type data, like we established here. Then we do a binary search on the data and the timestamp, because the timestamp is what's going to allow us to establish what is the correct value. Then lastly, in our binary search function, we do our left and right pointers. We'll then create a mid pointer, which will be inside of our while loop. We'll get the value of the timestamp at mid. And if mid is either less than or equal to the timestamp, great, we can push left to the mid. Otherwise, we push right to mid -1. Then our closest value is just going to be getting the data at left, since the left will be the smallest value or closest value. Then we compare the timestamps, and depending on that value, we either return a blank string or the value of the closest value. Anyways, guys, that's it for this one. If I didn't make anything clear, or if you have any questions, please let me know in the comments below. Otherwise, hit that like and subscribe button, show me some love, and I'll see you in the next one. Peace.